Hello, this video runs with the book, The Valuation Analyst, Research and Extracting Adjustment Rates, and it goes with Chapter 5. Now, some of the questions in this book are, that we're trying to answer. Why is it so hard for appraisers to extract adjustment rates? Another question might be, how accurate should an appraiser be when extracting and using adjustment rates? In other words, if it was a gross living area, if one appraiser uses $80 and one uses $90 per square foot, is that an issue? What if one uses $80 a square foot and the other uses $120 a square foot? Then the third question that the book looks at is, how do I settle on the best single point adjustment rate to use on the grid? Now, the third question is talked about in later chapters, but this particular video answers partly why is it so hard to extract adjustment rates, but is specifically designed to help answer the question, how accurate should an appraiser be? Now, you're looking at a kind of a convoluted spreadsheet I use for several things, but I also used it to answer the question, how accurate should you be, by setting up a very simple market model. Now let's look at this. We have some sales. I think there's 100 listed. And in this scenario, it only allows anywhere from 30 to 50 sales to be used. Over here, I notice that the sales prices are randomized by plus or minus 8%. And remember, when we say plus or minus 8%, that doesn't mean one's either plus 8 or minus 8. It could be a minus 8, minus 7, minus 6, all the way to 0, then 1, 2, 3 to 8. Actually, in this column, it shows what happened when it was randomized. Now, these are set up, the random, when things change randomly, these are done in macros, not on the spreadsheet, because I had some trouble with the spreadsheet resetting and recalculating when I didn't want it to. As a matter of fact, I've put a calculate button up here to calculate certain things. Now, the reason I had to do that is because the recorder I'm using, Camtasia, if you hit F9, which is Excel's button to calculate, it goes into pause. So I had to put a little calculate button here. So the gross living area, what's the coefficient for that? Well, the coefficient in this run was $61. It could be anywhere from 40 to 80. The age can be anywhere from a minus 2,000 to a minus 500 per year. And the pool can be 8,000 to 20,000. And if you applied these numbers up, for example, gross living area times $61, 28 years times the minus 1058, and one pool times 20. That's how you would get, I believe, this 115, and then it's randomized 5%, so it ends up being 121. So all in all, pretty straightforward. Now, I'm going to run this once. I'm going to click the run button here. And what happens when it runs, there it goes. When it runs, I'm going to go down and show you it actually runs a regression analysis on that. And here it is. This is what you're used to seeing, Excel's regression. And it said the pool's worth $18,007. You can see that right here. But we're more interested in this ranges over here. And we're doing 90% right now. We're looking at a 90% confidence interval. So what does it mean when you're returned with a regression that you ran a confidence interval? Well, what it means is this is saying that there's a 90% chance that the correct answer is within the range of $15,137 to $20,876. Now, the regression formula itself is descriptive statistics, but these confidence intervals, they run based on the Gaussian curve, or what we call the normal curve. And so that's a reason that I never use less than 30 sales in my tests, so that we can get a good reading. So basically our question is, if a returned regression relying on inferential statistics says that the range is from 15 to 20, we would not expect the appraiser to do as good as this regression. The regression is a very, very powerful calculator, and we would not expect to be able to do better. So on one attempt, or one run is what I call it, it would say anywhere, if the appraiser was anywhere from 15 to 20,000 for the pool, that would be good. All right. Now we know, because we're now getting to use some of the tools that we talked about in earlier chapters, like probability and randomness, and a little bit like Monte Carlo simulation. It's not a true Monte Carlo simulation because we're not really finding a probability, but we know that one average, like flipping a coin one time, it got heads. We would not make the assumption every time we flip the coin, it will be a heads. We know we have to run it many, many times. And in this case, we're going to run this like 5,000 times. So let's look at something. Now, first of all, I want to talk about an error that is in the books on the chart that gives the conclusion. And we'll look at that chart in a minute, and I'll show you there's an error in the width of the ranges, because there's like three things that we look at. We looked at the interval size, and right here in this column, we measure the interval size, okay? So I'm going to see, like the interval for the pool here, it's showing a plus or minus 15.9%. I'll run it another time. This time we got 20%. Now, what I want to talk about is what is the difference in the whole interval and the plus or minus interval. So here's I'm going to hit the calculate right here. Now, we've made this the same as over here for the pool. The low is $12,559, and the high for the range is $18,861. Now, where did these come from? Remember, that was returned in the regression under the confidence interval at 90%. So the whole range, let's think about the whole range. The whole range would be this 18,000 minus the 12,000. So the whole range is $632, okay? And when I say the whole range is 40.1%, that is taking the $6,302 divided by the mid-range, the 15,710. I don't use the high or the low, I always use the mid-range. Now, that's the whole range. Now, when I say plus or minus, that would be half of the whole range. It'd be plus or minus then the $3,151, or 20% going in each direction. Okay, so from 15, the midpoint, 15,000 over here to the 18,000, that would be 20%. Now, what the error in the book was, I had put plus or minus on my interval, and it was not a plus or minus, it was a whole interval. Now, this changed. You can look in the front of your book. If it says August the 3rd, 2018 and newer, this is corrected. If you have a book older than that, keep in mind, and I'll show you more closely in a minute, and you can make a note in your book on that. So let's do some more thinking about this. Let's run this again. I'm gonna clear this and run this one more time. Okay, this time it gave a 16.9%. Now, in order to make this, remember when one of these examples are shown, it's very specific to the example, but I want it to be a little more general. And that's why I let the things randomize a little bit, like between, somewhere between the -8 and 8%, but also the gross living area coefficients that the sales prices are based on change each time. So I can't just hit calculate and it'll change, because it has to run in the program, but it changes each time. And the gross living areas for all of these can change each time between, for example, the gross living area between 1600 and 2400. The age can change from 5 to 20, and the pool can change from 0 to 1. So what that does is it allows a little more general look at the picture. Now, I'm going to, just to show you, I'm just going to set this up and let it run 10 times. So I'm going to set it run 10 times. I'm going to say run. And then I think I made these smaller so everything you could see, or made these bigger so you could see. So this is the total plus or minus, which was 196, but we got to divide it by the 10. So we're really coming out 19.68%. Okay, that's the plus or minus. So the whole range is going to be, right below 40, 38, or 39. Now, basically what I did is I set this up at 90% and ran it 5,000 times. Now, let's look at the next sheet that I've got. Let's see here. Okay, now here's what's in the book. Now, here's where the error was. By interval here, this interval had a plus or minus in front of it. So I took the plus or minus out. Okay, so the pool at 90%, with 5,000 runs, the average range, the average interval size of the confidence interval at 90% was 36.9%. Now that's the average. Remember, there's going to be some way bigger than that. And on top of that, keep in mind that 10% of the time, we're not even going to be in this range. It's going to be outside of this range. So 36.9% for the pool and 51% for the effective age. That's the averages. That's pretty wide. So that's showing that with a relatively simple market, and over here's the information on the market, for a fairly simple market randomized by plus or minus 8%, even a powerful tool like regression analysis and using the confidence intervals shows that the appraiser's not going to get a close answer, okay? And so that's what this shows. Now, the next question we wanted to know is how many times was the correct answer for the adjustment rate for the pool within the interval. Now, keep in mind, let's say this again, there's 90% chance that it's within that interval. See how these are all about 90%? So that shows, that's just a check that shows the math is, the scenario and is set up fairly correctly. Now, the next thing I wanted to know, and it's maybe not too important, but I was just curious, is how often, is the actual answer usually close in to what what the regression predicts, or is it farther away? Now I'm going to come down and show you what we mean by that. So let's say we were doing gross living area and it was $100. Section B would be plus or minus 15%. So if the interval is a plus or minus 15%, then what is the whole interval? It would be 30%. So, but I wanted to know if it was plus or minus 15%, how often would the answer be in here? Was it evenly distributed or was more near the right answer? And it looks like they were closer to the right answer. At 90% interval, 66.8%, almost, it looks like maybe an average of around 68% of the time, it's going to be close to the right number rather than out on the far end. It's still going to be out on the far ends, but 68 is much better than 33% chance of being 33.3% chance of being in each interval. Then I did the same thing for the 95%. Then I averaged them. So if you average these, we would expect the appraiser to be within plus or minus 20% of the pool, or plus or minus at the 90%, looks like about 18.5%. Okay, so basically there's no single correct answer, okay? There's no single correct answer. Any correct answer within this range would be correct. So the best we can do is extract an adjustment rate in a wide range of possibilities. In later chapters, we'll look at ways and tools that we can use to pick the best single point from the different ranges that we get. So you can see that when I work what I call in my computer lab, I may try this, and instead of using 30 to 50 sales, I may try, let me get this in the screen. Instead of 30 to 50 sales, I may try 50 to 100 sales and see does that narrow, how much does that narrow the range, you see? So I spend a lot of time just testing different things, and that's why this spreadsheet has so much stuff on it. And I can tell you, although we have these wide ranges, even with regression does pretty good at picking the gross living area, I think because it's so strong. It's such a strong, dominant property characteristic. Okay, so that is the end of this video that runs with Chapter 5. Thank you.